So, last type, factoring. Today we're going to talk about perfect square factoring. So, recall what was the first method we learned on Tuesday? Common factor. What was the second type that we also learned on Tuesday? Group factoring when there's four terms. All right. Wednesday we did the triangle and square method for trinomial factoring, and then yesterday we did the cross multiply method for trinomial factoring. So today the last type is going to be perfect square. What are perfect square numbers? Jonathan?
Like 8 times 8 equals
64. Good. Another example?
4 times 4 equals 6.
Right. Okay. So if I list them out, they're going to be 1 times 1, 2 times 2, which is 4, 9, 16, 25, 36. These numbers right here, if you recognize these numbers, you're going to be able to do perfect square factoring in like 10 seconds. Okay. So the key to today's lesson is you have to recognize these numbers and that they are perfect square. All right. So looking at this, is 9 a perfect square number?
Yeah.
Is 1 a perfect square number?
Yeah.
Yes. So what's the perfect square for 9? 3. So 3a, 3a. Just like when we did the cross multiply method. What about 1? 1 and 1. Notice there's a minus sign in between, so it's just minus. And we're done. Wow. All right. And then as we just did on the board, no. Okay. Okay. What about example 2? Example 2. Yep. Yep. And 144 is 12 times 12. Okay. William, do you agree? He said 2 and 12. It is. 12 times 12 is 144. Oh, yeah, yeah. It goes on forever. The list goes on. Okay. Exactly. See, that's why I picked you, because William always sees the common factor. Alright. You see the common factor in all of them? You can divide by 4 everything. Does 4 go into 144? Yeah. So everything is divisible by 4. So as we said right here, the very first thing you should check is always common factor. So 4, and then y squared plus 12y plus, is it 36? 144 divided by 4, 36. Yeah. Okay. Now, but even though we factored out that 4, is this a perfect square? Because this is 1y squared, right? 1 is a perfect square. Is 36 a perfect square? Yes. So now, so then, what times what gives me y squared? Y and y. What about 36? 6 and 6. What sign should go here? Plus, because everything is plus. Okay. And so what's my final answer? Ethan? 4 in brackets, 5 plus 6. Perfect. It's too easy for you? No, it's like wait for a while. Okay. Okay, so Gavin, you're gonna help me with this next one. Okay. Example 3. I heard a Okay. So first off, is 4 a perfect square? Yeah. Is 81 a perfect square? Yeah. Yeah, so I know my two brackets what times what gives me the 2x, right? Okay, and then for the 81 is 9 and 9. So now you're thinking, when this was minus, it was minus minus. When this was positive, it was positive positive. But what about this one? There's no middle term. Sydney. Right, which is exactly what I already wrote right here. So in order for the middle term to cancel out, it means 1 is plus, 1 is minus. Can I simplify it any further?
Yeah. Probably not.
No, because they're different. So it's 2x plus 9 and times 2x minus 9. And that's your final answer? I can't simplify it any further.
Can't just do brackets 2x or no?
Huh?
Can't just put just 2x.
Nope. Yeah, it's we're factoring it. Oh, and let's just say I'm not sure that I factor it properly. You can do FOIL to see if you get the question. Okay. What about this one? Is 16 a perfect square? Is 36 a perfect square? So what makes 16? Okay, William? Ooh, remember we're doing perfect square, which means it has to be exactly the same, right? 4 and 4. Okay, and then this one? 6x and 6x, good.
And 1 plus and 1 minus, right?
And then 1 plus 1 minus, okay. Yes. Cindy, what do you realize? I can't just reduce it. I can't just shrink it. Right. Okay. And that's because what did I miss at the very beginning? My first step. You can divide them all. So when you get here, notice there's common, like this is divisible by 2, this is divisible by 2. So I know I missed something. I hope you didn't write using pen. Okay. So yes, what is the common factor between them?
4.
4. If it's a perfect square, it will still be a perfect square after you do the common factor. Okay, and you'll see that it's still a perfect square. Isn't it interesting how a perfect square will stay perfect square even after you divide it out? So then for the 4, it's going to be 2 and 2. For the 9x squared, it's going to be 3x and 3x. And since there's no middle term, what are my signs? Plus, minus.
There's no specific way they have to be, right?
Nope. Okay. So, what's different with this example is I had the constant and then the variable. So, when you write your factors, you write the number first. Okay. The order of like 2 plus 3x, 2 minus 3x, that matters. So if you did 3x minus 2, that would be wrong. Okay? So the order of how you write the terms matter.
So like we got 2 plus 3x because 4 divided by 2 is 2. And divided by 3 is 3.
Yeah, you can think of it like that. But because 2 times 2 is 4, 3 times 3 is 9.
Oh.
Okay. Okay, and then the last one, this one is the famous one. Okay. You use it in grade 11. You use this a lot in grade 11. Okay, so what are my 2 factors here? Gavin?
1.
Yep. So what my 2? Now that I know all the pattern.
1 and 1.
Yeah. 1x, 1x.
Minus 1 and plus minus 1.
Okay, but do I need the
Why?
do I need the 1? Do I actually need to write? Yeah. So in simplified term, this would be x plus y, x minus y. All right. So this is a famous property for difference of square. Yes.
If you were to write 1,
No. Yeah, but it just looks nicer like this. Okay, so in general, so if you have something like this, where you see a perfect square, you see a perfect square, middle term is plus, then is plus and plus. If it's minus in between, then it's minus, minus. And if there's no middle term, that means one is plus, one is minus. All right, final one. Who can tell me this one? All right, 9x squared plus 4x squared. What does this equal? Let's see. Okay, Jaden, what do you think?
3x minus 2y. 3x plus 2y.
Okay, so Jaden says, don't write this down yet, guys. So he says 3x, 3x, 2y, 2y, and then he said because there's no middle term, one is plus, one is minus. But if I expand this out, I'm not gonna get the same answer. Alright, Andy, what's wrong with his answer?
Because if you actually do it, you're gonna get a negative, and it's supposed to be a positive.
Mm-hmm. Okay, so what would the answer be? Sydney? 3x plus 2y, 3x plus 2y. But if it's a plus, I'm gonna get a middle term. You can't do it, right? What did I call this? What was the name for this?
A difference of square.
Difference of square. Difference means subtraction. This is not a difference of square. So can't do it. See, Gavin, you've been with me for math for 2 years, so now you know, can't do it. When I ask it like that, you know. Yeah. William.
Why would it make it negative?
Huh?
Why would it make it negative?
If you made this a negative, then Jaden's answer would be correct.
Why? Why isn't it correct?
Why?
Plus?
If you did 3x minus 2y and 3x minus 2y, you'll have a middle term like this, right? If it's negative negative, you'll have a middle term. If it's positive positive, you'll have a middle term. All right, but if there's no middle term, that means one is positive, one is negative, but it's not a difference of square. So if it's a plus, it doesn't work. Even if you recognize that 9 is a perfect square and the 4 is a perfect square, this is not factorable. Does that make sense or no?
No, but
If you don't trust me, you can do FOIL. Do FOIL, and then you'll see that none of the combination will get you to this.
I do trust you. Just
Okay, but it's just if you try it out, you'll see why it doesn't work. Okay. This property right here is called difference of square. So this right here, there's no rule for sum of square. It doesn't work. Okay. So as I said, if this was minus, then yes, it will work because then it will be a difference of square. All right. So that's it. Try these ones. Nice short lesson, 14 minutes. Try these. For today's lesson, it's really, if you try a couple more, you'll recognize the perfect squares. And then these questions, if you see it on the test, should take you about like 10 seconds to do. Okay. And then, yep. So on Monday and Tuesday, as I said, I know you guys some of you have the literacy test. So focus on that. And then we'll do the last part of this chapter, which is just zero and negative exponents. Something nice and easy. So you don't have to worry about it. Okay. Just worry about your literacy test. and then Tuesday, Wednesday review, Thursday the test. Sounds good?